Hi, my name is Ryan Madsen, and I am the instructor for Earth and Space Science. And this video just introduces this topic and gives a little bit of a taste of some of the things that we'll be doing. So, first of all, I want to talk about what it means to be a scientist. And if I were to rewrite this slide, I'd probably say being a scientist and an engineer. Okay, because when it comes to science, we not only include scientific principles, but we also include engineering principles. We use the scientific method, the engineering method. And it's important to understand when it comes to science, it is a method. It's not a bunch of facts. All right. That's a misimpression we have about science. Like, oh, science says this and science says that. No. Science is just an approach. It's an approach to discover what is correct or correct principles about our physical world. And I'm going to talk about how we use that in some different careers. And some of these might surprise you. I'm going to go through them kind of quickly, but some of these photos might surprise you because they aren't what you think about as a scientist all of the time. One example is a crime scene investigator. Now, a lot of us have seen different crime scene movies, and so we have a good idea of what these professionals do. Obviously, it's a little bit dramatized in those movies, but the concept is relatively correct. They come into a scene. There's a lot of evidence around. Okay, there might be fingerprints. There might be drops of blood. There might be something that is broken. There might be a window that's been pried open. All of these things are just evidence. That investigator then needs to use his or her imagination to visualize a story that fits this evidence. When they visualize that story, then they have to test that story against the evidence, and they need to then remove any biases, because even though they came up with this idea, they need to be able to revise that idea based on the evidence. And sometimes they need to be able to throw out ideas. So they might have felt really, really strongly that this theory was correct. But then when they see the evidence, they just see that it's not matching up. So a good investigator needs to throw that theory out and come up with a new theory. That process is really, really close to what a scientist does. In fact, it's essentially the same thing. We're going to have evidence put out there, and our job is to come up with the best explanation for it. Then test that to see whether that explanation holds up to the evidence. And when it doesn't, we cast it out, we toss it out, and we try something else. Some other ideas, just briefly touching on these. Somebody who trades stocks does something very similar. They look at data, which is essentially evidence, and they try to predict where a stock's going to go. Okay, if they come up with the correct explanation for why a stock is going up, and if it correctly explains that data, they might be able to predict where that stock's going to go. And if they can make money. On the other hand, if they have a theory that they don't even look at the data for, and they just say, hey, I just think this is right, and that's how it goes, they could end up losing a lot of money. But you can see in many ways where science is applied in business. And I actually worked in business for a long time. I worked in technology actually for a long time. And so I saw this scientific thinking all over the place. People who did well with it tended to do well with their business. People who didn't tended to not do well. But it's just an example of other ways that you might be using science in the future, even if you don't see yourself as a scientist in the future. In medicine, science is used throughout it. And when you go in to get a medication or you go in for a procedure, we better hope that that doctor has used science in discovering what the best methods are. And with medicine, there's no board that says this is what is true and this is what is not true. It comes down to individuals that are doing tests to see whether something helps or whether it doesn't help. And that's what we'll be doing as scientists. In athletics, if you're an athlete, you're probably using science all the time, whether you call it that or not. You're experimenting with different approaches to your training, to your skills, to your nutrition. And by doing that, when it helps, you continue doing it. When it doesn't, you throw it out and you try something else. Okay. And if you only have one approach, we've all seen that before. Some of us have seen people that are starting in a sport and they say, oh, no, I like to shoot the basketball like this over my head. It's better. Okay. And we all know, and it's like, no, this works better for me. And we all know it's like, well, let's look at the best approaches. Let's be willing to have an open mind. Let's be willing, even though we think something coming in, we need to look at the evidence about what works the best. Let's look at some other players, what's worked for them. And then we need to sometimes revise our strategies in order to be the most effective in our sports. Firefighting, I know that we have a lot of students who are looking at becoming firefighters. And the education to go into firefighting is called fire science. And that's not a coincidence. That's not a misprint. Fighting fires is all about science. It's about studying the data and figuring out the best approaches to be able to minimize the damage of a fire or to quickly put it out. And when you, especially if you're somebody who is directing the strategy for fighting that fire, you have to think scientifically. You have to think about, where is that fire getting its fuel? What's going to cause the fire to move more rapidly? We're checking weather. All of these things have to do with science about putting together a theory, testing that theory, and then revising it when we in order to improve upon it. Now, engineering in general is an area that is something that many of you have considered and many of you should consider. It's an expanding area where there's going to be tons of demand and a lot of, frankly, a lot of money is going to be paid to people that understand science well. And with engineering, it takes one little extra step where we understand scientific principles, but then we are creative and we find a way to apply those scientific principles so that they actually help people, okay? And they actually create some benefit. So they might help people, they might help communities, they might help governments, they might help even animals, okay? It could be all different types of, when we talk about helping people, it could be all different types of audiences that you are trying to help. But that's what an engineer does. They take scientific principles, they put them together to create something useful. Now, a lot of our students, I've talked to some, like to game, okay? Science is used throughout the game-making process, all right? And just one example, if you're a graphic artist, you need to make sure that you are using what we call physics realism. That means if a ball drops, it's got to drop according to physics principles, according to mathematical models of how things drop when they're in our surroundings. Now, you might think, well, nobody's going to calculate how far this ball should drop when it drops, so who cares? Well, the reality is, whether or not you calculate it, we know when something looks weird. You guys have all seen it in a movie when something doesn't quite go right, when something bounces wrong or launches too far. We pick that up. We know it, and it looks amateurish. It looks unbelievable, okay? And so using physics, if you're a graphic artist, is quite important. But there's science is integrated throughout the game making process, not just in the graphics. And finally, you might say, well, okay, I can't think of any way that science is going to apply to my future career. First of all, I have a hard time believing that. And if you think that's the case, come talk to me. And I think that I can show you how science will be involved in your future career. But even if there was a case where somebody didn't have any science in their career, you will be using science, or you should be using science when it comes to your personal decisions. One example of those personal decisions is when you decide to buy a medication. Okay, we'll all have illnesses. We might have different reasons that we need to buy medication. And sadly, and hopefully I'm not telling somebody something that they don't already know, sadly, there is a lot of false claims when it comes to medication and health. Medication and health are areas where there's a lot of scams that happen, okay, because people are sometimes desperate for a solution. And so sometimes they'll grasp onto things that make them feel like there is a simple resolution to a problem. And you see this in many areas. But what we want to do is we want to learn the scientific method so that we can evaluate when somebody says, hey, this pill is going to cure your illness, that we can look and we can say, okay, well, what evidence do you have for that? Because simply a celebrity saying that it works, that's not very good evidence, okay? That celebrity is being paid, first of all. right? And it's also just one person. They may actually even think it works, okay? That doesn't mean it works. Let's look at the evidence. Let's look at the studies they've done, see what the data shows. And maybe it works. That's great. And maybe it doesn't. And so we want to be able to make decisions. And science, really, a lot of it is really about making good decisions and using evidence and data to be able to make those decisions that are best in line with what our goals are. Something exciting about science is nobody owns it. I love this part of science, okay? There's nothing in science that is true because I say it's true, okay? There's nothing in science that's true because some professor says it's true, okay? Nothing in science is that way. There's no group of people that say, hey, we've just got to say what's true and that's the end of the story, okay? That's not how science works. Science is a method. Okay. And no matter who you are, including a student at Virtual Academy, you could come up with a better perspective on how the physical world works. Okay. And you could come up with a better theory. And if you disagree with something you hear in science class, guess what? If you come up with a theory that better explains the evidence, then you might change science. You might revolutionize it. And that's kind of what happened when Albert Einstein came up with his theory of relativity. He wasn't even working at a university. He wasn't working even at a high school. In fact, he was working as a patent clerk. And he did thought experiments and he wrote a paper that revised the way we think about the world completely, fundamentally. Okay. So was he the authority to do that? Well, there's no such thing as an authority in science. That's the thing I love about it. All of us can come together to come up with theories. And that's why I love the fact that many of you are going to come up with corrections for me. And that's great. I love to be wrong in science because that means I've learned something new. And I hope that you'll feel the same way, that when you learn something new, that's what's exciting about science. You're a detective in this process. You need to have an open mind. And here are some of your tools. You need to study the evidence. You need to keep an open mind. You propose a theory, then you test that theory. Now, this is not the end of the story. The end of the story is after you test the theory, you probably are going to find something wrong about that theory. So then you revise that theory. You come up with a new one. You study the evidence again. Then you, again, test that new theory. And this is a cycle that you go through. And when you don't just hold on to whatever theory you came with, but you're willing to test that and improve upon it, that's when you gain great insight and you discover new principles. And be open to being surprised. That's one of the best parts of science. I love it when I learn something in science that is just like, wow, I never would have thought that this is the way our universe worked. But isn't it cool? Isn't it cool to know how much we don't know? That there's so much out there that is beyond. We get into these patterns where we look at the world and we say, oh, we kind of get it all. I have it all down. I know everything there is to know. I love it in science when I learn something. It's like, wow, I had no clue. It's so different from my daily experience. And that's fun. It's fun to know what an adventure lies ahead. Be fearless. Okay. Don't worry about, don't fear knowledge. Okay. Knowledge is exciting. It's a journey, and be willing to delve into it. And then when it comes to, and this is a picture, science, and this is something I think that's really, really important. It won't be something that we talk about extensively throughout the course, but I want you to be aware of it. I have here a picture of a nuclear bomb. I have a saying, and that is, science can tell us how to build a nuclear bomb, but science cannot say anything about whether or not to use that nuclear bomb. This is where ethics come in. Now, the other parts of that, we have ethics. There's other terms like morality, also religion. Okay. Some people mistakenly look at science, and I've heard people say this. They look at science and they look at religion as if they are opposed to each other, as if you either believe in science or you believe in religion. That is completely wrong. Okay. Science cannot replace religion. And religion doesn't do a very good job of replacing science in certain areas. Okay. So what I encourage you to do is ensure that you bring ethics to that scientific process, because scientists need to be ethical. Okay, we can't just simply say because we found out something can be done, like a nuclear bomb, that doesn't mean we should use it. We need to have that morality, that ethics, that religion in order to be able to make those types of decisions. And obviously, those are personal decisions, and I will never tell you what you need to do. All I will say is that ethics are critical to the process, and we should never feel like those need to be left behind. And then, as we learn about science and as we incorporate that ethical side, we may want to take action. And that might come in many forms. For some of you, it might be that you decide you want to become a doctor. You might want to become an engineer. You might want to volunteer for a cause. For example, there are clean water projects that bring clean water to third world countries that save thousands of lives, and they're based on scientific principles. But taking action as we include ethics in our scientific process sometimes becomes a natural next step. And I want to conclude with just this quote because I think this really shows how science takes out a misconception that some people have about science. And that's a quote by Albert Einstein. He says, "Imagination is more important than knowledge." And why did he say this? Well, sometimes, like I said at the start, we have this misimpression that science is just a collection of facts. But the reality is that science is about discovery and about forming a new understanding. And in order to discovery begins with imagination. And we have to be able to visualize things that we sometimes can't see. We have to be able to be creative. We have to be able to be able to brainstorm and do all of these different things that allow us to discover. And if we only go off of what other people tell us, we're never going to be able to do what science is really about, and that is discover something new. So I'm excited to take this journey with you. I like this metaphor. I will commonly talk about our journey in science as a trek. I love hiking. I love trekking. I love backpacking. And as you know, when you're on a trek, you might have a trek leader. Okay. But that trek leader doesn't do everything. Okay. In fact, the trek leader sometimes might be helping you up, a hard ledge. But other times you might actually be helping the trek leader up a hard ledge. Okay. And that's how I want you to look at this process. We're working together. We're a team. We're on an adventure. No one of us owns that adventure completely. Okay. And we need to all participate in it. And as you know, on this adventure, as say, if I'm the trek leader, I might be able to give you some guidance and help, and I'm going to be there and make sure that you don't ever get left behind. But also, that I'm not able to simply carry somebody. Okay, they need to do their part. They need to put in that effort. They need to be willing to be open to discovering and to listening and to understanding. And so hopefully that's a way that you can think about this process. But I'm excited about it, and I look forward to working with you, and I look forward to getting to know what your interests are. So please do come and talk to me about the areas of science that you're interested in. And even if you don't think you're interested in science at all, just tell me what you're interested in. What are some of your goals? And I want to find ways that in this Earth and Space Science class, that we can incorporate those goals into some of our projects and labs, so that you can get closer to where you want to be in your life through the power of science.